Hey guys, Mr. Martin back here with you again on tonight's video in which we're going to use parallel lines and transversals. Let's get started. Alright, the first thing I want to do is give you a postulate that's going to set the stage for everything we need in this section. Okay? The postulate's called the corresponding angles postulate. Very simple. We learned last video how to pick out corresponding angles. Now, if we have two parallel lines that are cut by a transversal, then we've got four pairs of corresponding angles that are congruent. In this example, 2 is congruent to 6. There is also 3 other pairs that we talked about in class of congruent angles as well. Okay, so that is the first postulate that we need for everything else we're going to do tonight. Let's do an example. Okay, so in this picture now, because of the corresponding angles postulate, there are 3 other angles in this picture that are also 120 degrees. Can you identify the angles? Copy this picture into your notes, pause the video, and see if you can come up with the other 3 angles. Alright, we're back now. If you are back, I hope you got the right answers. Let's figure out the solution for this. Alright, so first step, by the corresponding angles postulate, we know that angle 1 is going to be 120 degrees, because that was given. Okay, but also from the corresponding angles postulate, we know that angle 5, which is the corresponding angle, has to also be 120 degrees. So like we were talking before, we've got to the left of the line, if we call this one line L and this one line M, we're talking to the left of the line, okay, on both of these. And if we call this, that was really sloppy, if we call this line T right here, then both of these are above the line T, or the transversal. So we know that this must be, angle 5 must be 120 degrees. Okay? Now, we know from vertical angles that angle 4, which is a vertical angle to the angle they gave us, also has to be 120 degrees. And then now we can say the corresponding angle for angle 4, so we can jump to the other group of angles, has to be 120 degrees. So those are the 4 angles. Angle 4, okay, angle 5, and angle 8, along with angle 1, which is the one they gave us at the beginning, all have to be 120 degrees. Okay, let's keep going. Okay, now from that postulate, we can easily prove some theorems. The first theorem that we can easily prove is the alternate interior angle theorem. It says that if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So this one has 4 and 5 as alternate interior. Remember, alternate meaning opposite sides of the transversal, and interior meaning between the parallel lines. So now we've got, for angle 4, it is on the right side of the transversal. Angle 5 is on the left side, and both of those are in between the parallel lines. Okay? So we know from the corresponding angles postulate, okay, that 1 and 5 are corresponding. Okay? But 1 and 4 are also vertical. So we say that the measure of angle 1 has to equal the measure of angle 5. And that's coming from the corresponding angles postulate. Okay? Now, obviously, the measure of angle 1 has to also be equal to the measure of angle 4, thanks to the vertical angle congruence theorem. Okay? Now we've got two angles, 4 and 5, equal to the measure of angle 1, so we know that the measure of angle 4 must equal the measure of angle 5, thanks to the ever-popular transitive property. Real easy proof. We just proved the alternate interior angles theorem. Okay? Let's go on to the next theorem. How about the alternate exterior? Okay? Real easy, simple proof again. Let's put angle 5 back in there. Okay? Angle 5 is the corresponding angle with angle 1. So we already know that the measure of angle 1 equals the measure of angle 5, thanks to the corresponding angles postulate. Okay? How about 5 and 8? The measure of angle 5 is equal to the measure of angle 8. Again, thanks to vertical angles being congruent. And then again, the good old transitive property says if we've got two different angles, this case 1 and 8, equal to the same angle, then they must be equal to each other. So the measure of angle 1 equals the measure of angle 8. Very simple three-step proof. Last one. Let's look at the consecutive interior angles theorem. Now this one's different. It doesn't say that these angles are congruent. It says that these angles are, okay, read the small print over there. It says these angles are supplementary. So remind me again, what does supplementary mean? Okay, it means that those two angles have to add up to be 180. So this one's a little bit trickier, okay, but let's do it. Okay, so let's put in angle 1 again, and we know, again, going back to our corresponding angles postulate, we know the measure of angle 1 equals the measure of angle 5 because of the corresponding angles postulate. I told you that postulate was going to be very useful. Okay? We also know that the measure of angle 1 plus the measure of angle 3 equals 180 degrees because they are a linear pair. So let's do some substitution. Let's take out angle 1, which is equal to angle 5, and let's put in angle 5 right here. Okay, so we know that the measure of angle 5 plus the measure of angle 3 has to equal 180, and that is substitution. And obviously if they equal 180, then we can say angle 3 and angle 5 are supplementary. And that's just coming from the definition of being supplementary. Can I put SUPP? Okay. Good, so 3 very quick, easy theorems. First one said alternate interior angles are congruent. Second one said alternate exterior angles are congruent. And the third one said consecutive interior angles are supplementary. Don't get those confused. Okay, everything so far was congruent until we got to consecutive interior. All right, let's use this information. Got an example for you. Okay, here's a picture where they gave us some angles and they want us to find the measure of to find the value of x. So once we find the value of x, we can find the measure of the other angle. Okay, so what do we know about angle 4? I want you to think about that. Pause the video. See if you can tell me what x is, and then see if you can also tell me the angle, the measure of that angle down there. Okay? Lots of ways to tackle this. I'll see which method you'd like to use. Pause the video and come back. Alright, so we got the answer, I hope. Let's see what we can figure out. I see a lot of things on this picture because I know the two lines are parallel. I know alternate interior are congruent. So I know that this angle right here has to be x plus 5. I also know, thanks to vertical angles or corresponding angles, this angle up here has to be x plus 5. So now I've got a lot of information I can use. Okay? I also know that thanks to vertical angles, angle 4 has to be 115. Okay? So we just solved from the consecutive interior angles theorem that consecutive interior angles have to be supplementary. So we can say that 115 plus x plus 5 has to equal 180 degrees. Again, these are going to be supplementary because those are consecutive interior angles. Okay? So let's solve for x. We got x plus 120 equals 180. So we subtract 120 from both sides, and we end up with x equals 60. Okay, so let's come back up to our picture, and let's erase what was there before, and let's put an x of 60 in there. So if x is 60, this would obviously equal 65, which would make this 65, thanks to vertical angles. This would be 115 because of a linear pair, and we know from the corresponding angles postulate that those two angles are corresponding and they better be congruent. So it looks like we figured it out. Right? Let's look at just a formal solution here. Okay, this is the solution they presented in the book, and it says by the vertical angles theorem, angle 4 is 115. Okay, line A and line B are parallel, so we can use any of the theorems about parallel lines. Notice, one thing I didn't point out at the beginning of the video, every single one of these postulates and theorems that we just talked about tonight revolves around those two lines. Before you start applying those theorems, look for... Oops, let's get back to the right place here. Hey, sorry about that. Remember, all of these theorems and postulates that we talked about tonight revolve around the lines being parallel. So we have to look for the marks on the lines that indicate the lines are parallel. We cannot assume just because they look like they're parallel that they are. Those red arrows there tell us that those two lines are parallel to each other. So all of these postulates revolve around the two lines being parallel and cut by a transversal. Alright, that's all I have for tonight. It's a real short one tonight, hopefully. And you can work on some practice problems in class tomorrow. Have a great night, you guys.